focused on Bioflow. So now I'm going to share my screen. The dynamic for today is going to be a little different because we are going to start showing the slides. So as you can see, there are very few slides, and then we can continue with a live demo. When I finish the presentation, Laura is going to share the link to, if you want, you can follow me using the link access. So again, this is a tool developed for statistical support for breeders, geneticists, and leadership in decision making. In reality, this is a tool designed for everyone. All of you can use it without matter your actual role. Who is this involved? Who is involved in this Bioflow initiative? So
Luis,
here, yeah,
can you
tell me.
please share the presentation in presentation mode so everyone can see it in full screen?
Yes, I can do that, but let me extract my computer from the document because otherwise it's not going to work.
Okay.
Yeah, now I'm ready to. Let's wait for 1 minute, please.
Sure.
Yeah. Mm, Can you see my entire screen?
Yes,
In a
now we
presentation?
can see.
Okay.
Thank you.
Who is involved in this Bioflow initiative? So currently, there are involved in this initiative all the CG centers, so CIMIT, IATA, SIP, ICARDA, the Alliance itself, IRRI, and African Rice, but focused on the biometrics capacity CGIR centers. Last year on October was the first meeting to planning the developing of this tool. That meeting was in the Cairo in Egypt. The second meeting that we had was this year. Actually, it wasn't a meeting; it was a hackathon to improve the actual development for that time, and that hackathon was in Nairobi. So right now we are planning to perform a second hackathon, yeah, most likely on November. The main goals of Bioflow, there are several, but I'm going to highlight the more important: instant access to cutting-edge methodologies and one-stop breeding analysis for CGR centers and also for the national partners that we have in each country, standardize the data analysis pipeline across the CGR centers and also across the NARS. Actually, for the first time during this year, we need to report the genetic gain of the all CGR centers using Bioflow in order to standardize the way to make this reporting. Also, faster breeding decision and less human error. This tool also reduces the reliance on manual time-consuming inquiries because I'm going to show you later, but the tool allow me to access the data located in different database sources and quick and easy access to breeding data and metrics for evaluation of breeding program performance that can give me more time in this case for breeding management for breeding manager quantitative genetic expert to focus on new methods or do other more meaningful things. In terms of the biostatistics outcomes, this is all about, I'm going to talk today, because the Bioflow has different modules, and the most important for me is the biostatistic module. So in this case, we are able to perform phenotypic data analysis using any model, no matter what kind of experimental design do you have in field. Because we are able to perform, for example, single heritability, all of the steps that are involved in the single thread analysis, like extract the single blue values. Also, there are there is another module called multi-environmental thread analysis to perform the GIGWA analysis, uh, to perform the selection index using the desired approach. And if you are interested, we can also make a report of genetic gain estimations and optimal cross selections. Like I said before, the tool is able to connect to different database sources like BreedBase. So in my case, BreedBase is where we locate our data, because Cassava Base is part of the BreedBase ecosystem. But for the other programs, there are other different data sources like EBS and BMS in case of the BIM program. Here you can see the technical design. Actually, this is an application developed using a Shiny framework called Golem. So here you can see that we can input different data sources omic in terms of the phenotypic data, or in case that you have marker data, you can input to the application, pedigree data, environmental data like rainfall, humidity, temperature, and also a target product profile data. So the application is able to calculate and report the GBEs, the selection indices, the genetic gains. In case of the genetic gains, we have two different approaches: the realized genetic gain and desired genetic gain, optimal crosses. So just to know, the application in this moment is under developing, so we are planning to add more features in the future. Here you can see the technology used. Um, like I told you, the entire application was built using the R Shiny framework called Golem. So that means that all of the calculations that we will have are based on R Studio language, R language, R program. So for the data storage, we are using Amazon. And also, this is an open source project where all of you can do your respective, for example, pull requests or modifications that you like to see in the applications. So I'm going to talk about this later. For the for the Shiny and the UE and the interoperability, we are using Shiny Golem framework. And for the deployment, we are using Docker Posit. How can I contribute to this project? It's so easy. The only thing that you need to do is go directly to the GitHub repo account, just clone the entire repo. Can be Bioflow repo, or can be, for example, the function box, the base functions repo. It depends where you wish to add your modifications. So let me show you. Here is the GitHub repo, CGI Breeding Analytics team. So in any of these different repo, you can add your modifications. So for example, Bioflow is the main repo, but if you want, you can add some basic functions in the CGR base repo or in the CGR pipeline. Here is the scan in case that you want to go directly to the GitHub repo. And here is the front page, front view of the application or tool. So currently there are two different links to access. One of them is the CGR Market Intelligence. This is the recommended for everyone because the other, the Bioflow EBS project is only for CGR centers. So in the case of you want to use the EBS servers, uh, link, you need to request an user and yeah, an user because based on that you will able to create a password. But for the first link, it's not necessary, no credential requires. So now I'm going to go directly to the application. So please, Laura, can you share the link in the chat for everyone?
Yes, I have shared it.
Okay. For the purpose, I'm going to use the CGR Market Intelligence because it's the link that is available for everyone. So here, as you can see, there are different modules. Also, very important to mention that in this moment there is available an entire tutorial. Just clicking here in this YouTube logo. So one of the main collaborators that we have in here called Joanny Eduardo Covarrubias, um, he did this tutorial for each module that we have in Bioflow. So please, in case that you want to go deep, it's necessary to go directly to the tutorial. Also, another thing that I'm going to show you is the About Us section. Is mainly is part of the you already know. But here you are able to also to meet the team behind of this developing, and also in case that you want to contact and make any modification to the main application, you can contact the Bioflow support desktop following this link. Okay, the first step that we need to be aware is just how can I retrieve a new data? So here there are different submodules called phenotypic data, genotypic, pedigree, QTL profile, and also in case that you want to add climate data, you are able to extract the weather data. So for the purpose of today, I'm going to work only with phenotypic data because phenotypic data is the only data set that is necessary to perform the entire analysis. But in case that you have genotypic, pedigree, and QTL profile, you can add this kind of data sources. So let me show you another thing. You can upload a file directly from your computer, also a copy URL in case that you have the data set in any kind of GitHub repo, for example. And this is the most interesting function that I can show you today in terms of the data retrieve, because thanks to Brapi, we are able to extract or to make a query to different data sets, database, for example, EBS, BMS, and BreedBase. For the case of BreedBase, we don't require to have credentials because BreedBase is completely open. So here you can put the link of the database. For example, in my case is Cassava base. So let me bring the Cassava base link just to show you how it works. Only thing that I need is the link. One moment, please. Yeah, just paste here and let me save this. No authentication required. This is no, going to be the same for the case of the EBS or BMS. So in this case, it's just a click to log in into the database. And for the case of the breeding program, so obviously, I'm going to select, for example, CIAT, and in this moment, the application is retrieving the trials from CIAT. It sometimes can take time, but in other situations can be faster. And here you will be able to select the organization, the folder, the folder that in this case was set by our data manager. So for our case, we have our trials organized by countries and also by years. So in case that you need, for example, a historic trial carried out on 1997, you will be able to extract and download all trials conducted in this year in this folder. This is the way that we can retrieve the data using in this case, BreedBase database. But for the case of the demo, I'm going to upload a data that we have prepared. So let me show you here quickly. Mm, this is the data I already prepared for the demo. In case that you want to follow this live demo, because you don't have this data, you can load the example. The tool has an example preload ready to be analyzed. So here you can see the preview of the data set. So for example, we have in this moment two different trials, the GR column, the trial name column, the trial. This is a data set typical of cassava base. The first columns that you are going to see is the metadata, and the last columns are going to see the variables taken during the harvesting. So in this case, the data set is already uploaded. So next, we need to match the columns with the columns that the application has. So for example, here, there are one of them that are mandatory, like designation, for example. In this case, designation is the most important column because it's the accession name. So let me look here for the accession name. Accession name, trait, you are able to analyze several traits or just a single trait, two traits, the traits that you want to analyze at the same time. For this time, I'm going to select just two traits, like for example, yield. And let me show you other. Um, Dry matter gravity and dry matter and yield. These are one of the two two important traits for the cassava case. Other that is very recommended in this case is the yeah, that's it. That's it because as you can see, the others are not mandatory. So here you don't have to be worried about the experimental design. So as you can see here, the tool is now asking you about what kind of experimental design did you perform, because like I said, the tool is able to detect the different factors that you have in your trial. So for example, in this case, we have a call number, we have also row number and rep number. But there are other cases that the only factor that the experimental design has is just, for example, rep number or I block number. So the tool is already programmed to detect what kind of experimental design and perform the, uh, the correct model to apply. So next step is define the column environment. So here there are suggested columns that, for example, in my case, the column that I need to select is just trial because the way that we call our trial names is the same way that many of the crops call environments. So in our case, I only need select trial. There are programs that, for example, you need to concatenate different columns to define the environment. So in my case, it doesn't apply. So let me just select trial and compute environment column. And that's it. Here, the environment column was already computed because the environment column is the other most important column because all of the analysis is going to be performed based on the environments. And yeah, uh, uh, the data is ready to continue with the first analysis. So in case that you want to add other data sources, for example, genotypic, the tool is able to upload, for example, HapMap, BCF, CSV formats. For the pedigree, it's important to take into account that we need to add this data source for the case that we are planning to conduct a genetic gain analysis for QTL profile. In case that you have, go ahead, you can load the QTL data source. And for the weather, this is very nice because you are able to see the API NASAPOWER to extract the data. So for example, here in this moment, we have two different environments. For the case of each environment, we need to put here the latitude and longitude, also the planting date and the harvesting date, and the extraction interval that you wish, for example, daily, monthly, or hourly. So the application is going to download the rainfall, the temperature, and the humidity. And yeah, and that's it. So let's continue with the first analysis. For this case, the selection is the first module. So the first
Luis,
punch, yeah.
maybe what we can do is wrap up in these next 5 minutes in
Okay,
case more people
yeah.
have questions specifically about what you're talking. Probably they will have curiosity about other options there or
Okay.
questions about the tool itself and research. Yes?
So, okay, I'm going to do just these two modules and that's it. The
Okay.
quality assurance is the first module, so where you are able to detect any kind of outlier, not only for phenotypic data, also for genetic data. So let me show you how it works. For this case, I'm going to detect for the two traits. And also here we can see, for example, not the distribution, the dispersion of the data records. So here there are two records that in this moment are tagged like outlier, but you can modify this IQR coefficient in terms that you want to detect more outliers or less outliers. So I'm going to let like this 2.5. Um, yeah, okay. Let's continue with the run analysis, tag outliers, and the tax outliers I already detect. For this case, we have two different outliers for the yield trait. And also we have here a little report that if you want, you can download the report is available for sharing with your breeders or to showing the advanced meetings. This report is an HTML file. Yeah. So let me continue with the other module, single trial analysis. For the case of single trial analysis, so so I think that many of you know what is the single trial analysis about, but just To be concise, is just to extract the blues values and the single heritability within each trait. So here we need to select the previous data set, analyze in the QA step. Yes, let's pick the traits. So in this case are yield and dry matter by gravity. So let me show you here the different distribution of each trait. Pick effects in case that you want to add any effect and run the analysis. So in this case, the tool is conducting the single trial analysis for each trial. So just let's wait a couple of minutes, a couple of seconds. And that's it. We have here, for example, the number of accessions within each trial, also some of the summary statistics like minimum value, mean value, maximum, the compute single heritability, the coefficient of variance, the R square, the variance, the genetic variance, and also the residual variance. Mm, so like I told you before, so in this case, the tool was able to detect that my trials had row and column information. And that is the output of this SPATS evaluation. And also we have here the proportion of variance within each trial. Mm, here we can see different parameters in terms of the bar plot, for example, in this case mean, or if you are able, if you want to see, for example, the heritability and the predictions. The prediction in this case are the most important, no for selection, but these predictions are the same that are going to be used to conduct the GIGWA analysis that is the next step. But because of the time, we are no, I'm not going to show you the next steps. Thank you very much.
Thank you, Luis. Thank you very much for this presentation. And it's good to see that we have 87 participants on today's seminar, and I see a lot of claps. So it's good to have participants that are interested in this topic. So I will open this space for questions. I have some questions myself, but I will leave them for people to start participating. And I left some questions for the participants. Maybe you can start with that. For those who are new to Bioflow, what's the first thing you hope to learn or apply from today's session? And also, Luis said that this tool supports decision making in various roles: breeders, geneticists, leadership. So, which of these roles do you identify with, and what's your main goal for using a tool like this? So, please open your mics, turn on your cameras. Luis, if you would like, you can stop sharing. In case they ask more about how to use the tool, you can start sharing again, but it will be good to see each other faces for this conversation.
Okay, yeah, thank you.
So,
Thank you, everyone.
thank you, Luis. Please raise your hand and start asking your questions. We have one from Latir. Go ahead, Latir.
We cannot hear you, Latir.
Yeah. Good afternoon, everyone. Thank you,
Good afternoon.
Laura. Thank you, Liz. Yeah, I appreciate your presentation. But I have just one single question about Bioflow. Because previously I was working in a nurse in Senegal, and I was working as a cotton scientist, but now I am working with a SIAT based in Senegal office as data science. So my main concern is what is the difference between Bioflow and BMS? I think you, as you are working on genetics, you heard about BMS, breeding management system, used by most of the scientists in, I think, Africa rice. Yeah, so I don't know the difference, the main difference between Bioflow and BMS.
Okay, well, so to be honest with you, I'm not familiar with BMS because, like I told you, the breeding management system that we use within the cassava program is the BreedBase. But based on your question, I think that both are the capabilities to make the same calculations. But with Bioflow is completely open, free for everyone because as far I know, I think that to access to BMS, we need to account you with a user and password.
Can
Yeah,
I
but
add, Luis?
yeah, go
Sorry that
ahead, Eduardo. Go ahead. Yeah, yeah.
yeah,
Thank
no,
you.
thanks,
Welcome, Eduardo.
Latir. That's a good question. Indeed, at some point, Latir, we decided that we wanted to decouple the data storage from the analytics. As you know, BreedBase, BMS, EVS, they have some analytical capabilities, but the core, business of those platforms is storing the data, being able to run an experimental design, and just set the trials, the operations. But when it comes to analytics, you have to bring together genotypes, phenotypes, QTLs, environmental information, and probably as we move forward, more and more types of data. And it's impossible for one database to have everything integrated. Instead, we decided to just decouple it and put the analytics as some sort of satellite that it just extracts data using APIs, bringing it together and do more sophisticated analysis. As you know, in BMS, you also have, it's actually one of the few databases that had a lot of analytical capabilities, but that is coupled with some additional licensing because it's going through BSNI. And as you explore Bioflow, you will notice that actually even BMS doesn't have all the capabilities that we are putting in Bioflow. There's he showed two modules, but actually there's some pretty sophisticated things over there. GBBs with factor analytic and multiple GIGWA models that also regress over environmental covariates, etc., etc., etc. But I hope that helps a little bit. Latir, I don't want to expand or repeat myself, but feel free to respond.
Yeah, thank you for your answer. Maybe the last one is for the experimental design. When you are presenting, you were saying that after you select the trait and the environment or the location, I mean, you don't need to select the experimental design you are using. So yeah, if you can explain more, I did not really understand how the analysis will be done if you don't
Yes.
select any. Yeah.
Yeah, because because the tool is able to detect what kind of experiment, no, not directly what kind of experimental design you did use during the planting, but it's able to detect what factors are involved within each trial. So you know that depends of the factors that we have is going to define the experimental design. So, for example, for the live demo example, we just select we only select the call number, row number, and rep number. That three factors. So the Bioflow tool was able to detect that with using these three factors, the experimental design that we use was a spatial, a row called a spatial experimental design. So for example, in case that you only have replication, the Bioflow is going to detect that the experimental design was a randomized completely design, and for the others, experimental design works in the same way. So please, Eduardo, correct me if I'm wrong. And by the way,
No, I
Eduardo
think
is one of the main developers of the application. So welcome, Eduardo.
that's a pretty good answer, Luis. Just maybe to complement, indeed, we use an experimental design agnostic approach. Pretty much anything that you have, Latier, is going to be fitted. You can have trials that have completely different experimental design. Imagine that you upload your data and you have one is RCBD, the other one is alpha, the other one is CRD, etc., etc. And for some, you will have rep, for some, you will have row, for some, you will have column, for you will have both, for some, you will have incomplete block. And what we're going to do is, as long as you have information for that trial on rep, we feed rep. As long as you have information for that trial, you know, in row and column, we will feed row and column. If you have both, we will feed a spatial kernel. And that's pretty much the story. Trial by trial, we check what factors do you have available, and those will be fed.
Yeah, very useful in case to perform a historic analysis where you not always have the same experimental design.
Okay, thank you.
Yeah, welcome, Atir.
Thank you, Latier, for your questions, and thank you, Eduardo and Luis, for the answers. Is anyone else with a question? More people are
Someone
joining.
rise.
I see one from Hugo. You can go ahead.
Hi, Luis Fernando. Thank you for your presentations. I have a simple question. You mentioned that it's possible to estimate with the tool selection index, genetic gain, and other parameters that are relevant in plant breeding. Are they following the manuals of excellence in breeding?
Yeah.
Yeah. So all the workflows that are
Okay.
explained
Yes,
in
yes,
these
yes, yes.
documents, in those
Yes.
manuals, match.
The
Yeah,
methods
yeah.
are those.
They are following all of the recommendations that Excellence in Breeder made us. For
Okay.
example, in terms of the selection index, there are two different methodologies, but the recommended is the desired approach. So you are able to select accession based on the desired approach. And also for the heritability is the same history. And for the rest of the analysis.
Okay, thank you. That was my first question, and I have a second question that is
Yeah.
about the accession names. But I think that will depend more of the data set that will be upload in the software, and there is no way to standardize maybe the accession names in the analysis that we will do in the platform, because sometimes happen that if you are analyzing data from different regions, you can have different names for the same varieties that are not standardized, but that will depend more of the source that you are loading, of the data that you are loading, I guess, and is not nothing to be with the platform.
Okay, to avoid that, it's highly recommend that you gather the data directly from the database. Otherwise, you will need to do extra work in terms of the cleaning the data. Once the clean data is ready, is going to be uploaded to the application, because otherwise, it's not going to work.
And can
Okay.
I add something to complement? That's a good answer,
Yeah,
Luis.
yeah. Go ahead.
And you know, we allowed to upload data for two different types of, let's say, identifiers: the name, which is what we call designation, but also the GID. And you know, you have, let's say, those two options, so you can also always perform an analysis not at the level of designation, but at the level of GID, in case, you know, that somehow makes your life easier, because maybe something has a different name, but it has the same GID, or the other way around. But that will be all, of course, very dependent on your database.
Okay, thank you both for your answers.
Thank you, Hugo. We have a question from Roy. I see that he lowered his hand, but I don't know if Roy, do you still have the question?
The question is already answered. I think it was already asked, so that's why I lowered my hand.
Okay.
Yeah.
Thank you, Roy. And we have a question from Jacob.
Hi, Luis, everybody.
Hello,
Thanks
Jacob.
for a very nice presentation. I have a question in terms of the community that you're having around the tool. So it's a GitHub open source community. And also so we are building another tool, and Hugo is also involved around ClimUp with R scripts for on-farm testing, and also working with Brapi. What do we need to do to engage with you guys on like collaborating?
I think that the most suitable person to respond this question is Eduardo. Eduardo,
Okay.
can you please help me with that?
No, I think you can also come up with a good answer. But Jacob, no, we're always happy, to engage with more people. As you saw, it was mentioned that you can always, just clone the repositories, which is just the Bioflow and two main packages, which is the pipelines and the basic functions. And what we expect is that you come up. Let me put this in some plain words. The major strength of the Bioflow is not really, let's say, the modules, but the fact that we have come up with a standardized data structure, which goes through the different modules. All the modules always take the same data structure. They do whatever that has to be analyzed, and then it spits out the exact same data structure. That way, it doesn't matter where it's going to be analyzed. It can be still reused by the other modules. So I would say, as long as you relate yourself with the data structure, which is just a list, in an R data object that is somehow, used in the calculations, you can create a function, which is, let's say, a pipeline and additional functions if you need it, that takes that object, does the calculation, and the results are put in that same data structure. And that's good enough for us. Then you can just push those functions to the packages. We will merge them, and if you have some people that is able to do the interface as well, so just a quick shiny app, you can also push it to the Bioflow, or you can also tell us, hey, I know how to code in R. I have the pipeline, but I need support to do in the interface. And if it's within the scope of Bioflow, which is using the evolutionary forces for the purposes that were explained at the beginning, then we will happily engage with you to create the interface for that function that enriches the environment of Bioflow, which, as you said, on-farm trials is always of interest. We have been developing something a little bit on that, but I'm sure that we can leverage a lot from experts like you, Jacob, that are kind of leading this space. So yeah, just reach us out. Also, if you want to join the hackathon, join us in November. And every time in the hackathon, we just explain how everything works in detail one day, and then the next days people is just basically working, developing functions, developing interfaces, and that way we make kind of the initial progress for the next months of the year.
Great. Where will the hackathon be, Eduardo?
In Dubai, for the convenience of everyone.
Okay. Thanks.
Okay, welcome, Eduardo
Thank you,
and Jacob.
So we have reached to the end of the seminar. It was very good to see the questions you have. We will also leave the emails from Luis, and maybe Luis can also give us some contact information. In the page, we can see that there's a contact us section that you can also use in case you want to understand how to use the tool or how to apply it with whatever you're doing right now. And we will share the recording and also the notes of this seminar. So if you have any questions, please reach out to me and I will connect you with anyone that is involved in this project. So thank you very much, everyone, and thank you again, Luis, for your presentation, and Eduardo for all the support.
Yeah, thank you. Thank you very much, Laura, for the invitation, and all of you guys for being here. So yeah, let's please keep in touch. So don't forget that in the application, in the module About Us, is a link that you can go directly us. Thank you very much.
Okay. Have a good day, everyone. Bye-bye.
Okay, bye-bye, guys. Thank you.